bottle, man.
Hey.
Putting that in the way. Jeez,
Giving me all these orders, pushing me around. You think you're boss here? You're not the boss of me. This is Mark Tommerdahl, Mr. Bossy, and Bob Dennis back with Grumpy Science. Yeah, we're kind of extra grumpy today.
Yeah.
So, Mark's going to talk about something. I have no idea what, because this is all unscripted, just, you know.
We're actually both reading from a script right behind the monitor.
Yes.
Yeah.
So what is it we're going to discuss today,
Well, I
Dr.
believe, we got an email. Well, we got a lot of emails, actually. And
alarming
probably
number of really
a
long
good time
emails
to mention that is that I think we're going to end up branching out to answer some of the emails. Right now we're going to answer this one. But, hopefully the Brain Gauge YouTube channel will be online very shortly. And in that, I'm trying to answer more specific questions about Brain Gauge, and Bob's going to do the same thing for pulsed electromagnetic field.
Yeah, it'll be on this channel,
right?
Because I have a lot of the Micro-Pulse ICES stuff. It won't be Grumpy Science. It'll have a title with ICES-PEMF in it.
He'll probably wear his bow tie for that one.
I may just do that. I may invite Professor Know-It-All, who knows a lot more than Mark or I. He even knows more than he knows.
Yeah.
So
well, anyway, for those of you that are familiar with the Brain Gauge, it's okay if you're not, which we can talk about it. But what we're going to do is talk about one of the specific measures, and that's called TOJ, or temporal order judgment. You know what measure that is, Bob?
The measure of when things happen with relationship to other things.
Yeah,
sure.
basically
temporal order, the order
of things
happening.
The way that test is done is that the Brain Gauge stimulates one finger and then stimulates the other, and you respond as to which one you felt first. Now, obviously, it's randomized and all that.
And the difference in time can get really small.
It usually starts out at about 100.
Starts off as oh, that's easy. Then it goes that's kind of easy. Then well, not so easy, right?
Yeah, very good sound effects.
I'm the sound effects guy. I have been ever since high school. That's how I was so disruptive.
Even though it worked really hard so it didn't make any noise, but he just blew that.
That's right.
Let that out of the bag.
Yeah, so much for that.
Well, TOJ is basically sort of a frontal striatal measure, and it's very useful. It's just by itself, it's fairly useful. But most people will score in the normative range of about 20 to 30 milliseconds.
Did you all catch that? When he says a good frontal striatal measure, that means
if you mess up that part of the brain, then that's not going to work. Now,
it's a measure that we take with a brain gauge that doesn't correlate with. It involves a specific function in a specific area of the brain that we can measure.
Yeah, and so now if you mess up the entire brain, you have trouble with this as well.
They end up like me.
Yeah, and schizophrenics have real trouble with this, but their measures are just off the charts. They can't seem to comprehend order. A lot of other neurological insults will have trouble with those measures, but not nearly as bad. And but most people, again, 20 to 30 milliseconds. Now,
that's how close two events can be tactily, where you can still tell the difference barely, right? Yep. Much less than 20 to 30 milliseconds, kind of dicey. More than that, it gets easier for most people.
Right. And so the question that we got, which this leads up to, is that the person was alluding to some of the stuff they'd read on the website, was about how do you deliver illusions. And basically, most people are very aware of optical illusions. Everybody's seen optical illusions and sort of has an idea what those are. Well, optical illusions are interesting in that, or any illusion's interesting in that, the brain is what's connecting the dots. And so if you actually have dysfunction of connectivity, if the brain's not connecting the dots, then you can actually see things, you can see through the illusion.
Right. Your brain doesn't process it and filter it and add in the illusion. So this strange counterintuitive reality of the way the brain works is that in some cases, with a brain injury, you will see things more accurately than they really are.
Yep, exactly.
Yeah.
And so we designed an experiment back in 2006, I guess, first time we tried this, where we said, let's deliver an illusory stimulus to the skin and do TOJ. And the illusory stimulus is a very, very weak vibration that we did on the two tips of the skin, on the tips of the fingers. And then on top of that very weak vibration, you do the taps, the two taps. And do you know what happened?
Actually, I don't know what happened there.
Well, I mentioned, most people were pretty good at about 20 to 30 milliseconds.
That I know.
But then they got a lot worse.
Oh, I understand. Yeah, that's right. I know what this one is. So you're sort of priming.
Hold
on a sec. Let's turn the monitor. Let's turn the monitor on.
Click.
Hold on. Click. Open that window. And
all right.
Okay.
And so here's our data. Ignore this side. We're just talking about TOJ right now. Okay, so when we did this, we had to write a whole bunch of papers.
Let's zoom in on the monitor.
Yeah, zoom in on it
a little bit. Yeah, we'll zoom that monitor in a little bit so people can see it better.
Okay, zoom in the camera. All right, so let's just look at this side. TDT is temporal discrimination threshold. That just means you can tell the difference between the two. But the TOJ, temporal order judgment, okay, these numbers, smaller numbers are better. This is not like your brain gauge scores. This is the nerdy way to show it, and this is the way we used to do stuff because it made sense to a bunch of academic geeks, and that's the way, well, it made sense to me anyway.
Yeah.
Anyway, smaller numbers are better, and so we displayed
like golfing.
The roll, yeah, something like that. Raw data here. So on the controls, basically we normalized everybody's value, and we saw that value of 1.0, people were good to about 30 milliseconds on TOJ, but then they got a lot worse. The numbers got really a whole lot bigger when you added the illusory stimulus.
So you add this illusion in there, this illusory stimulus, and it made things a lot worse.
Yeah. Well, since this is grumpy science, I can tell you, when we sent this in for review,
tell the truth here.
Yeah, when we sent this in for review, there were a lot of grumpy reviewers.
Oh, man. To see new stuff.
Okay, because here we are. We're coming up with this idea about, okay, so I said basically what that's showing is that this is functional connectivity. And I'm saying, well, if you stimulate these few fingers, just tell me, in just practical terms, what do you think happens when the hand starts doing something together? It's a haptic response. When you grab something, do you think each of your fingers are independently acting, or do you think they're acting as a hand?
I think I know the answer to that one. We'll call on
Yeah.
I think they're acting as a hand.
Yeah, exactly. It's a haptic response. So after about 120 milliseconds of this synchronized pulsing, all of a sudden your fingers are going, whoa, hey, let's work together. It doesn't take long because, obviously you would not be very coordinated in your moves.
brain tries to streamline its information processing loads, right? So
exactly.
if it can see two things that it knows are not the same source, but they kind of go together, and it'll dynamically change. So it sort of starts to look at those two things as one thing.
Yeah. So because we had some grumpy reviewers, because back then they did traditional somatosensory testing.
We're not the original grumpy scientists. There were plenty of grumpy people before us.
They were like, oh no, that's called masking. And like, masking is the most ridiculous term. And they said, oh no, you're just confusing people with that other stimulus. It's just making it harder. And I said, well, let's prove it. So how would we prove that those vibrations? Those vibrations that are making the cortical ensembles, the cortical circuitry next door to each other, acting together. How would we prove that it's actually not masking? What they called masking, which was any kind of noise.
Mm-hmm. Oh, you're asking me a question?
Yeah, I am.
How do you prove it? Well, you do a test in a subject population that doesn't have that ability.
Yeah, well, before we did that. I'll just go back.
Okay, I'm sorry, I jumped ahead to stealing his thunder again. That's my job.
Yeah.
Sorry.
Well, there's multiple ways to prove it. One, you could look at another neurological disorder that has no functional connectivity, and they should have reduced functional connectivity. You could deliver specific stimuli which were just as intense.
All right.
As a vibration on your fingers. And actually, we delivered stimuli that were even more intense to show, oh, we're going to deliver a big masking stimulus because they said it was masking. But my theory is that as long that the stimuli, because they're coordinating activity between those two fingers, because it was making those two fingers feel like one cortical representation, one finger, one hand, the stimuli had to be exact. So we did multiple conditions. We did the condition where the stimuli were synchronized and periodic. We did them where they're asynchronous and aperiodic. And we did a totally random stimulus, which is very ugly.
So we got different combinations of whether a stimulus is repeated or not, whether they're...
And the bottom line is the only time this worked is when the stimuli were identical.
Right.
Had to be exactly the same for a certain amount of time. And there's a lot of timing parameters so that, so for you people at home that are building your own brain gauge and writing your own code, which, well, we got, last count, we got 3.5 million lines of code in that thing, but you go ahead and
good luck with
knock
that.
yourself out. Not on this particular test. But anyway, and you can also say, does a neurological population, which is hypothesized to have reduced functional connectivity, would it have the same effect? And then obviously, guess
that
what?
was the question I asked. So
that was the question he asked.
Reduced functional connectivity, do you see the same illusory effect? And the
answer is it's a very reduced illusory effect for autism. It's also reduced for concussion, also reduced for migraine.
So when you have a dysfunction in the brain that inhibits your ability for your brain to create an illusion to represent the world, when you lose part of that function, the effect of the illusion drops down.
Yeah,
It's
exactly.
you don't see it so much anymore.
Right.
And that's a measure, even though the brain is seeing reality more clearly as it really is, it's a measure of a loss of function of an important thing the brain does.
And it turns out that all those ways that I just showed you and talked about, well, that still wasn't enough for some grumpy people. That's just not good enough. So let's go to our next slide
here.
We got to go to the next slide. Try not to rip one slide where we take off the other one. There we go. Okay. Now let's talk. We might have to. I think we can see that pretty well. All right. So now we're going to talk about animal data. And what we did was we simulated this in an animal. And this was many years ago, and I don't do these experiments anymore, so PETA, just leave me alone. Anyway, you stimulate digit 2, and look at this. Basically, when you have this big stimulus here, you get this activation right here. I should use a pointer.
So digit 2 should be this one, right?
So right here, when you stimulate one digit, and we're looking at the cortical representation here, you get all this activity. Look what you get at digit 3.
Which is the other finger.
Not a whole lot.
Not a whole lot.
We add the conditioning stimulus, which is actually drawn a lot bigger than it really was.
Right. So it's a little bit of a preconditioning going on.
Just a little preconditioning, but you have that preconditioning on both digit 2 and digit 3. You get activation in the cortical representation at digit 2 and at digit 3. So imagine if all of a sudden with that conditioning stimulus, the activity in your brain is going bing, bing, both places with one stimulus.
So is it correct to say, because I'm not the expert, Mark's the expert, so just let me be the student in class. Professor Tommerdahl, I have a question.
Yeah, okay.
Yeah, I know I asked too many questions. So is it correct to say that in this first 2 stimuli between digit 2 and digit 3, you only see the response on digit 2, not so much on digit 3, but then when you precondition them with a little bit of what we're calling illusory stimulus, the brain starts to represent the 2 as 1. And then when you get a stimulus on 1, you actually get a response on the other finger. Is that correct?
That is correct.
All right.
And so try to imagine if you're doing the TOJ test and you stimulate one digit and then you stimulate the other. Oh, look, stimulate this one. Well, that was digit 2. That came first.
So we're tricking the brain into starting to represent this finger and this finger together in the brain. They're with a little bit of stimulus for a little while. It dies off after a while. It's not a permanent change. It's starting to represent these 2 fingers as together because they're getting similar inputs. And so it starts to say, okay, well, I'm going to simplify my computational burden by just looking at them as the same thing.
Right. And then, so it feels like both digits are firing off at the same time. So you have a real hard time telling which of these is going.
But that's a normal, healthy function of the brain, and it turns out when you can't do that, it's a problem.
It's a problem.
There's a lot of other things you can't filter out then, and and you actually lose function even though you're seeing the stimuli more clearly.
So if we could put the last slide back up.
The last slide. Let me call. Let's open that window up.
Let's hit the back key.
Yeah, we got to hit the back key on that window.
And so the interesting part about illusions is that when you have functional disconnectivity or something wrong, you actually perform better. Remember, smaller numbers are better. So over here, autism's actually outperforming the controls
because the illusion, the size of the bar, is smaller.
Yeah, they don't fall for the illusion.
So this is autism. That blue bar is like, there's the illusion. I ain't falling for it. Here's the healthy person that's not autistic. Is that correct to say? They sense an illusion because their brain is functioning properly with all the. It's building an illusion-based representation of the world based on all the stimuli it's recently seen. That's a normal function of the brain that you don't see, even though the person with autism is perceiving the stimuli more accurately because they're not layering an illusion on top of that.
And this gives you a really good way to measure what we call functional connectivity, and it's in your extended battery on the brain gauge.
Yeah.
So now, I mentioned all these different ways that we proved that we were actually looking at functional connectivity in the somatosensory cortex.
And there's still grumpy people who don't believe it.
Yeah. So there was one more way, and this was like a heroic experiment that our friends up in McMaster did with us. And basically, can you guess what they did?
Actually, I can't guess. I think I remember, but go ahead.
Okay.
Sorry, Mark. I don't remember this.
Well, basically, what they did was they had people do the TOJ carry this TOJ with the illusion, and during that sequence, and they kept doing that test over and over and over. And this is one of our retest publications. We've got 7 or 8 or 9 or whatever. Anyway, they keep doing it over and over for about 45-minute period. But during that period, they have TMS applied to
transcranial magnetic stimulation.
Yeah, applied right across here to the somatosensory cortex. I have a hat. I can't take my hat off. Anyway, they apply it to the parietal cortex, and you think their measures got better or worse?
I don't know the answer to that.
Okay,
I think their
so
measures
they're basically
probably got worse.
They're inhibiting the somatosensory cortex, a part that processes the sense of touch, and their TOJ scores got better because they actually blocked the illusion with inhibition, and TOJ, the determination of which one came first, that determination actually goes on somewhere other than somatosensory cortex.
Yeah, so let me sort of translate it from brain scientist nerdy speak to electrical engineering nerdy speak, right? So what we're doing, what he's talking about was a transcranial magnetic stimulator that uses FDA approved for all kinds of things, using it to interrupt these signal representations in the somatosensory cortex.
Interrupt the circuitry.
So interrupting the circuitry, and when you interrupt the circuitry, you get the same deficit in your ability to build this illusion, and therefore, because you've got this deficit in your brain's ability to build up an illusion of reality, it just simply sees the stimulus as it really is.
Exactly.
But which is quite interesting. So it's counterintuitive.
Quite cool. Anyway, that was
brain is very complicated, and you know, next time you're frustrated with somebody, you're like, you know, you're living in this make-believe world. Well, I got news for you. The healthier you are, the more make-believe the world is that you're living in.
So I think this is one of our more elegant experiments and elegant things. And then, so right after I present this, and then somebody walks up to me and says, "Oh, you guys only measure reaction time." I'm going,
right.
Really?
Yeah. It's a little bit more nuanced than just like, oh, this one's faster, you know, or this one's first.
Anyway, if you want to read the papers, there's a bunch.
Yeah, we'll continue to put links. So we've got people already saying, "Hey, where's the links? Where's the links?" Well, they're coming. You know, I'm running behind a little bit. But you should be able to look down below these videos within a week or two, and we'll have links to specific papers and references. And you can always email us, or, you know, with questions, you can always ask for more information.
For this, you can always go to the Cortical Metrics publications page and type in TOJ or
we'll put links there so that you can see things. But if you have really technical questions that relate to papers that we talk about, virtually all of those that relate to brain gauge measures are on the Cortical Metrics page in the library.
Yep.
And you just click on the library, and there's maybe 50 or 60 papers there. Or something like that.
There's over 100 papers there now.
Over 100 papers there.
So anyway,
I haven't counted them.
yeah, I quit counting. But anyway, we've got, quite a bit of that. And boy, maybe we can just get right under the wire for 20 minutes.
Yeah, let's not make
We're
it
gonna
20.
get another. We're gonna make that other guy
It's
really
been real.
mad.
It's been fun. It's really been real, especially if you have the inability to make things illusory. See you later.
See ya.